January 13th, 1952. Donner Pass, California. High in the Sierra Nevada mountains, winter had turned the landscape into something brutal and unpredictable. The wind was screaming across the peaks at nearly 80 miles per hour, throwing snow through the air like sand in a desert storm. Visibility had dropped so low that even the railroad tracks seemed to disappear into the white chaos. Then suddenly it happened. A sleek passenger train. The city of San Francisco, one of the most luxurious streamliners in America, slammed into a massive snow slide and stopped instantly. Just moments earlier, it had been racing through the mountains carrying 227 passengers toward California. Now it sat frozen on the tracks, surrounded by deep snow and unstable slopes towering above. The train wasn't just delayed. It was trapped, and on Donner Pass, being trapped in winter was never a small problem. For decades, this mountain had been one of the most dangerous sections of railroad in North America. Storms here didn't simply drop snow. They built walls of it, thick, heavy layers that packed together into something railroad workers grimly called Sierra cement. Snow so dense it could stop locomotives like a brick wall. But snow was only half the danger. The real threat was what waited above. Across the steep slopes surrounding the railway, weeks of snowfall had created unstable layers of heavy snow stacked on top of each other. At any moment, gravity could pull those layers loose and send thousands of tons of snow crashing down the mountain. Avalanches. And on that night, the mountain was loaded. Rescuing the passengers would require reopening the railway line through miles of buried track. Ordinary equipment couldn't handle conditions like this. Wedge plows and hand crews would take days, maybe weeks, to dig through drifts that deep. So the railroad called in its last line of defense, a machine built specifically for wars against winter, the Rotary Snowplow. These machines were enormous steel beasts weighing nearly 100 tons, equipped with a giant spinning wheel of blades designed to chew through solid snow and throw it far away from the tracks. Railroad workers had a nickname for them. They called them war wagons, because when the mountain buried the railroad, these were the machines sent to fight back. But even war wagons had limits. As the rescue operation began, the storm only grew worse. Blinding snow continued to fall, while avalanches thundered down the surrounding slopes. One rotary snowplow was buried by a slide before it could reach the stranded train. Another became trapped while trying to push through the storm. Still, the railroad crews kept working. One of those crews included an experienced engineer named Raymond Holland. In the middle of the blizzard, Holland and his team were trying to reopen the tracks so supplies and rescue equipment could reach the trapped passengers. The wind howled, snow piled higher, and the mountain watched. Then, without warning, another avalanche broke loose above the work site. Within seconds, the snow crashed down the slope and swallowed everything in its path. When the storm finally passed and rescuers reached the train, something almost unbelievable had happened. All 227 passengers survived. Every single one walked off that mountain alive. But one man did not. Engineer Raymond Holland died while trying to keep the railroad open during the rescue. And that raises a question that sits quietly at the center of this story. Why did men risk their lives operating machines like the Rotary Snowplow? To understand that answer, we have to travel back more than 60 years, to the moment when someone first imagined building a machine powerful enough to challenge a mountain. Long before rotary snowplows existed, winter was the railroad's greatest enemy. Every year, as cold winds swept across North America, the railroads that connected the continent slowly began to fail. In places like the Rocky Mountains, the Canadian prairies, and the Sierra Nevada, winter storms didn't just slow trains down. They stopped them completely. Snow in these regions didn't fall gently. It piled up. Storm after storm would bury the tracks under drifts that sometimes reached 15 or even 20 feet deep. Wind pushed the snow across the open landscape, packing it tightly against the railway lines until the tracks disappeared under solid white walls. And when that happened, the railroad had very few options. Their main weapon was something called a wedge snowplow, a large triangular steel blade mounted to the front of a locomotive. When the train moved forward, the wedge would split the snow and push it to both sides of the track. In light snow, it worked well. But in serious storms, the wedge plow created a new problem. Instead of clearing the snow completely, it compressed it. The snow became packed and hardened, forming thick banks along the railway that grew higher with every storm. Railroad workers soon gave this dense, what Snow a grim nickname, Sierra Cement, because once it packed together, it behaved less like snow and more like concrete. Eventually, the wedge plow could no longer push through it. The locomotive would slam into the drift and stop, powerless against a frozen barrier. And that's when the real work began. When machines failed, the railroads turned to men. Thousands of laborers were hired every winter to clear tracks by hand. Armed with shovels, picks, and sometimes explosives, these workers marched into the mountains to dig the railway out of the snow. The job was brutal. Workers often spent 12 to 16 hours a day digging through deep drifts while storms continued to bury the tracks behind them. Temperatures dropped well below freezing, and the wind cut to their clothing like knives. But the cold was only part of the danger. Above them, the mountains held something far worse. Avalanches. Snow on steep slopes slowly builds pressure as more layers pile on top. Eventually, the weight becomes unstable, and entire sections of the mountainside can suddenly collapse and slide downhill at terrifying speed. For the men clearing the tracks below, there was usually no warning, no time to run. Every winter, workers disappeared under sudden snow slides. Others froze during long operations in remote mountain passes. Some were crushed when heavy snowbanks collapsed while they were digging. Railroads rarely spoke publicly about these deaths. But inside the industry, everyone knew the truth. Keeping the railroad open during winter was costing lives. And yet the railroads had no choice. The Transcontinental Railroad had become the iron backbone of the United States, carrying mail, passengers, and freight across thousands of miles. If the railway shut down for weeks every winter, the entire economic system of the American West could grind to a halt. The problem was clear. The mountains were stronger than the machines. And unless someone found a better way to fight the snow, winter would always win. In 1869, while railroads across North America were still fighting a losing battle against winter, the idea for a completely different solution came from an unlikely place. Not from a railroad engineer, not from a factory, but from a dentist's office in Toronto, Canada. His name was Dr. J. W. Elliott. By profession, Elliott spent his days repairing teeth and caring for patients. But outside his clinic, he had a different obsession. Like many people living in Canada at the time, he watched the railroad struggle every winter as snow buried tracks across the country. To most people, the problem seemed unavoidable. Snowstorms were simply stronger than the equipment railroads had available. But Elliott kept asking a simple question. What if the problem wasn't the snow? What if the real problem was how the railroads were trying to fight it? At the time, wedge plows were designed to push snow to the side of the tracks. But pushing snow had a major flaw. Every storm added more snow to the growing walls along the railway, until eventually the plow could no longer move forward. Elliott began thinking about a completely different approach. Instead of pushing snow aside, what if a machine could cut directly through it? He imagined a rail car with a giant rotating wheel mounted at its front. The wheel would be covered with steel blades. As it spun, the blades would slice into packed snow like a giant circular saw. But Elliott's idea went even further. Once the snow was cut, it wouldn't simply fall to the sides of the track. The spinning blades would throw it far away from the railway, launching into the air and clearing the entire path ahead. In theory, the machine wouldn't just move snow, it would remove it completely. In 1871, Elliott officially patented his design, one of the earliest concepts for what would later become known as the Rotary Snowplow. Confident in his invention, he approached railroad companies and investors with his idea. The reaction was immediate, and not in the way he hoped. Railroad executives looked at the drawings and quickly dismissed the concept. To them, the machine seemed far too complicated and expensive to build. The idea of mounting a massive spinning blade wheel on a rail car sounded dangerous and impractical. After all, no machine like that had ever existed before. So the railroads ignored him, one after another. Investors rejected the project. Elliott's invention, a machine that could potentially solve one of the railroad industry's greatest problems, remained nothing more than a set of drawings on paper. Years passed. Winter storms continued to bury the tracks. Workers continued to dig through snow with shovels. Trains continued to sit stranded in mountain passes. And the dentist's strange idea gathered dust. For 15 years, Elliott's design went nowhere. But inventions have a strange way of waiting for the right person. Because somewhere in Ontario, there was a machinist who would eventually see those forgotten drawings and understand something everyone else had missed. The dentist had imagined the machine, but the real challenge was still ahead. Someone still had to figure out how to build it. Ideas are powerful, but ideas alone don't clear mountains. For 15 years, Dr. J.W. Elliott's design for a rotary snow machine remained nothing more than a sketch, an interesting concept that railroad companies believed could never work in the real world. Then the drawings reached the hands of a man who understood machines differently. His name was Orange Joe. Joe was not a wealthy investor or a famous engineer. He was a machinist from Orangeville, Ontario, the kind of craftsman who spent his life surrounded by metal gears and tools. His hands were rough from years of work, and his mind had been trained by experience to see what others missed. When Joe examined Elliott's patent, he immediately recognized something important. The idea was brilliant, but the design itself had serious problems. Elliott had imagined a spinning blade wheel that could cut through snow and throw it away from the tracks. But he had not fully solved the mechanical challenges behind that idea. The blades in his design wouldn't cut snow effectively, and there was no reliable system for throwing the snow far enough away to keep the track clear. In other words, the concept was right. The engineering was not. Most people would have stopped there, but Joe didn't. Instead, he began rebuilding the entire idea piece by piece. He redesigned the blades, shaping them into curved steel plates that could slice into dense snow, while guiding the broken pieces inward toward the center of the machine. He then created a system of chambers and deflectors that would catch the snow and force it upward through a large chute. That chute would become one of the most important features of the machine, because instead of pushing snow aside, the rotary plow would launch it into the air, throwing it far away from the railway so it couldn't slide back onto tracks. But designing the system on paper wasn't enough. Joe needed to know if the machine could survive the forces it would face in the real world. So before building the full-size plow, he created test models and brought them to an unusual testing ground, the sand dunes of Ontario. Why sand? Because packed sand created resistance similar to heavy snow. If the blades could cut through sand without breaking, they might survive real winter storms. For years, Joe experimented. Blades snapped, gears failed, mechanisms jammed. But slowly, the machine improved. 7 years passed before Joe finally believed the design was strong enough to build at full scale. In the winter of 1883 to 1884, he partnered with two Toronto businessmen, John and Edward Leslie, who owned a machine shop capable of building the enormous device. The first full-size rotary snowplow was constructed and prepared for testing. Railroad officials gathered to watch the experiment. Many of them expected the machine to fail. After all, they had seen plenty of inventions promise miracles before. But when the engine started and the blades began to spin, something extraordinary happened. The machine rolled forward and struck its first snowdrift. Instead of stopping, the snow exploded outward in a towering white arc, thrown nearly 20 feet away from the tracks. For the first time in railroad history, a machine had done something no wedge plow could ever accomplish. It didn't push the snow. It destroyed it. And in that moment, the rotary snowplow stopped being an idea. It became a revolution. At first glance, the rotary snowplow didn't look like the kind of machine that could defeat a mountain. Sitting quietly in a rail yard, it resembled an ordinary freight car, heavy, box-shaped, and mounted on standard railroad wheels. If you didn't know what you were looking at, you might walk past it without a second thought. But the front of the machine told a different story. Mounted on its nose was a massive circular, housing nearly 11 feet wide. Inside that steel ring sat the heart of the rotary snowplow, a giant spinning wheel fitted with curved steel blades arranged like the petals of a mechanical flower. Those blades had only one purpose: cut through whatever stood in front of them. When the machine was operating, the blade spun at tremendous speed, striking packed snow and breaking apart with violent force. Instead of allowing the snow to pile up around the tracks, the spinning blades dragged the shattered snow toward the center of the housing. From there, the machine's internal system took over. Inside the plow car were several powerful steam engines, constantly burning coal to produce the pressure needed to drive the blade assembly. Pistons pumped, gears turned, and the main drive shaft transferred all that energy directly into the rotating blade wheel. Once the snow was cut and pulled inward, curved steel channels redirected it upward into a large discharge chute mounted above the housing. Then the real spectacle happened. The snow didn't simply fall away. It was launched with incredible force. The machine hurled the snow high into the air, sometimes throwing it 20 feet or more away from the railway. Observers often described the sight as a giant white fountain exploding beside the tracks. It was mechanical violence disguised as engineering. But there was one surprising detail about the rotary snowplow that many people didn't expect. The machine couldn't move on its own. The spinning blades had their own power system, but the plow itself had no traction engines to drive it forward. Instead, the machine relied on locomotives pushing from behind. And in serious winter conditions, that required serious power. On mountain routes like Donner Pass, it often took 3, 4, even 5 steam locomotives just to push a single rotary plow into deep snow drifts. Even then, the progress was slow, very slow, in heavy snow. The machine moved forward at only half a mile per hour, roughly the speed of a person walking. Any faster, and the blades could clog with dense snow faster than the chute could throw it away. When that happened, the entire system could jam. And when a 100-ton machine jammed in the middle of the snow drift, there was only one solution. The crew had to climb out into the blizzard with iron bars and hammers and break the ice loose by hand. This wasn't a rare emergency. It was part of the job. Because the rotary snowplow wasn't designed for comfort. It was designed for war. A slow, grinding battle between steel and snow, fought inch by inch across the frozen mountains. The rotary snowplow was an extraordinary machine. But the truth is, the machine alone didn't keep the railroad open. Men did. And operating one of these massive war wagons required far more people than most imagine. Behind the rotary snowplow were several powerful locomotives pushing the machine forward. Each locomotive needed its own engineer and fireman, men responsible for controlling the train and feeding coal into the boilers to keep the engines running. If 4 locomotives were pushing the plow, that already meant 8 men working just to move the machine. But the rotary itself had its own crew. Inside the plow car, a separate plow engineer controlled the spinning blade assembly. Firemen worked constantly to maintain the pressure in the steam engines that powered the blades. Mechanics monitored the gears and drive shafts, making sure the machine didn't tear itself apart under the enormous strain. Yet the most dangerous job belonged to men standing at the very front of the operation. They were known as the spotters. Their position was terrifying. Spotters stood on small platforms at the corners of the rotary housing, while the machine slowly pushed forward into the storm. Their job was to watch the snow-covered tracks and signal the crew if something dangerous appeared ahead. And danger was everywhere. Buried rocks from avalanches, broken rail sections hidden beneath the snow, signal posts, or track equipment completely covered by drifts. If one of those obstacles hit the spinning blades at full speed, the results could be catastrophic. The blades would shatter, sending steel fragments flying like shrapnel. So the spotters had to see the danger before the machine reached it. The problem was that storms often reduced visibility to only 20 or 30 feet. Communication wasn't much easier. The rotary snowplow was unbelievably loud. The roar of the spinning blades, the grinding of gears, the pounding steam engines, and the howling wind all combined into a wall of noise that made normal conversation impossible. Orders were shouted, hand signals were used, and everyone hoped the message was understood. Inside the machine, conditions were just as extreme. The firemen working near the boilers endured intense heat from the steam engines, while freezing air blasted the outside of the car. Workers often finished their shifts with frost forming on one side of their clothing, while the other side was soaked with sweat. Shifts were long, exhausting, and often continued through the night. But perhaps the most dangerous task involved maintaining the machine while it was running. The giant blade assembly depended on constant lubrication. Without grease, the bearings could seize under the enormous stress of cutting through packed snow. The problem? The grease fittings were located near the spinning blade wheel itself. Crew members had to open a small access panel and carefully apply lubricant while the machine was operating, just inches away from the rotating steel blades. There were no emergency shutoffs, no safety systems, only experience, and the understanding that one mistake could cost a man his hand. That's why the men who operated these machines gave them their famous nickname, war wagons, because every time the rotary snowplow rolled into a storm on Donner Pass, it felt less like a job and more like going to war against the mountain itself. For decades, rotary snowplows gave the railroad something they had never had before, a real chance against winter. Storms still buried the tracks. Avalanches still roared down the mountainsides. But now there was a machine powerful enough to fight back. Every winter, the war wagons pushed through the drifts, grinding forward inch by inch, reopening the railway and keeping the lifeline of the American West alive. For a while, it almost seemed like the mountain had been defeated. But mountains are patient, and Donner Pass had been killing travelers long before the railroad ever arrived. The danger was never just the snow on the tracks. The real danger was the snow above the tracks. When heavy winter storms roll into Sierra Nevada, they carry enormous amounts of moisture. The snow that falls here is not the light powder found in other mountain ranges. It is wet, dense, and extremely heavy. Storm after storm piles new layers onto the slopes, building pressure inside the snowpack. Eventually something gives. Sometimes the trigger is a temperature change. Sometimes it is another snowfall. Sometimes it is simply the vibration of a train passing below. When that pressure releases, the entire mountainside can collapse at once. Avalanches on Donner Pass move with terrifying speed. Thousands of tons of snow can break loose and surge downhill in seconds, sweeping away anything in their path, trees, buildings, and trains alike. Railroad workers understood this risk better than anyone. But the work had continued. Over the years, there were close calls, derailments during storms, machines damaged by falling debris, and collisions during dangerous winter operations. Most of the time, the crew survived, but the mountain was always watching. Then came the winter of 1952. It would become one of the most severe winters in the recorded history of Donner Pass. Storm after storm buried the Sierra Nevada under staggering amounts of snow. Drifts grew deeper, avalanche zones became unstable, and clearing the tracks became more dangerous with every passing day. Then disaster struck. On January 13th, the passenger train city of San Francisco became trapped by a massive snowslide high in the mountains. 227 passengers were stranded on the frozen railway, while blizzard conditions made rescue nearly impossible. The railroad, immediately launched a massive emergency operation. Rotary snowplows were sent into the storm to reopen the tracks. Crews worked through freezing temperatures and violent winds, trying to cut a path through the deep snow before conditions worsened. But the mountain was already under enormous strain. During the rescue operation, one rotary plow was buried by an avalanche before it could reach the stranded train. Another machine was derailed while attempting to push through unstable snow. And then the mountain struck again. Engineer Raymond Holland was working alongside the rescue crews, trying to restore a damaged rotary plow so it could continue clearing the railway. The storm raged around them as the men struggled to keep the operation moving. Then, without warning, another avalanche broke loose from the slope above. The slide crashed down onto the worksite, burying everything in its path. Raymond Holland did not survive. Incredibly, every passenger on the stranded train was eventually rescued. All 227 people were brought safely down from the mountain after several days trapped in the storm. But the cost of that rescue was one life. And it was a reminder of something every railroad worker on Donner Pass already knew. The rotary snowplow was powerful. The crews were skilled. But in the end, the mountain always had the final say. In the end, the rotary snowplow was more than just a machine. It was a solution to a problem that once seemed impossible. Before its invention, winter storms had the power to shut down entire railroad networks for weeks at a time. Snow blocked mountain passes. Freight stopped moving, and the promise of a year-round Transcontinental Railroad often collapsed under the weight of winter. But the rotary snowplow changed that. Starting in the late 19th century, these machines began to appear across the northern and western railroads of North America. Lines across the Sierra Nevada, the Rocky Mountains, and the northern plains adopted the powerful spinning plows to keep their routes open during the worst storms. And slowly, something remarkable happened. The railroads stopped losing every winter. Freight trains carrying food, timber, coal, and manufactured goods could now move through mountain passes that had once been completely impassable for months. Mail arrived on time. Passengers traveled across the country without long seasonal delays. In a very real way, the rotary snowplow helped make the American West economically possible year-round. But the machine's story was never only about steel and engineering. It was also about people. Men like Orange Joe, the machinist who transformed a forgotten idea into a working machine, never received the recognition they deserved. Business partners took control of the manufacturing rights, and over time Joe's name faded from the story even though the machine existed because of his work. And then there were the operators, the engineers, firemen, mechanics, and spotters who spent long winters fighting storms in places like Donner Pass. They were the ones who climbed into the cabs during blizzards, listening to the roar of the blades while pushing forward into snow drifts taller than houses. Their work rarely made headlines. Most of the time, success meant nothing dramatic happened at all. The tracks were cleared. The trains kept moving. The country kept running. Over time, technology improved. By the mid-20th century, many steam-powered rotary plows were converted to diesel power, eliminating some of the exhausting maintenance required by the older machines. New snow-clearing equipment was developed as well, reducing the need to operate the rotaries as often. But the machines never disappeared completely. Even today, several rotary snowplows remain in reserve on railroads that cross the Sierra Nevada. Most of the time, they sit quietly in storage yards, maintained and ready, waiting, because the mountains still produce storms powerful enough to defeat modern snow equipment. And when that happens, the old solution returns. The giant blades spin again. Snow erupts into the air in a towering white arc. And once more, the railroad sends its steel war wagons back into the storm. In the end, the rotary snowplow represents something larger than a clever invention. It represents the stubborn determination of engineers and workers who refused to let nature close the roads they had built. The mountains never stopped fighting. But neither did the men who built the machines to challenge them.